Hello, Math 005. This lesson is on 5.4, addition and subtraction of polynomials. So example 1, write an equivalent expression by adding. What this means essentially is to combine all of our like terms. Before we can combine like terms though, we have to eliminate parentheses. Now think back to some earlier sections. If we had something that was maybe set up like this, how would we get rid of our parentheses? Correct, we would distribute. We'd take 3 times x to get 3x and add it to a 3 times 2, which would be 6, and that would eliminate the parentheses. We have to do the same thing here. However, you'll notice that we don't see any numbers in front of these, so we think of there just being ones in front. Now, anytime you distribute a positive 1 to anything, it doesn't change because 1 is that multiplicative identity. So when we distribute a 1 to everything, we're getting negative 5x cubed plus 6x minus 1, and then distribute a 1 to the second polynomial to get plus 4x cubed plus 3x squared plus 2. Now what we have to do is we need to combine our like terms. What I always recommend is to reorder it in descending order. That way it just makes it a lot easier. So the highest exponent here is going to be 3. So we have 5x cubed, and then we also have, so we use that one, and we also have plus 4x cubed. The next highest degree is going to be plus 3x squared. Then we have plus 6x, and then a minus 1 and a plus 2. Now it makes it very easy to combine our like terms. So we have to combine these two right here, which would be negative 5 plus 4, which would be a negative 1x cubed. We don't have to write the 1. And then we have this plus 3x squared plus 6x, and then lastly we have negative 1 plus 2, which leaves us with plus 1 as our final answer here. Go ahead and try example 2. Pause the video, and then once you finish, unpause it and check your answer. You can see here we get x cubed minus 2x squared plus 4x minus 3. You can go ahead and check your work with mine if you need to see if you made any mistakes, see if you can find it. Now, what all of this at the bottom of the page is it tells us how we can check to see if we did this right or wrong. You can read through these, but I will kind of quickly outline them for you, but I want you to at least give them a shot with your calculator. So number 1 says comparing graphs. This check is only partial, meaning it doesn't always work. However, for a lot of the stuff that we're doing, this will work good enough. But as you work through your higher classes, this might not work. So step 1, type the original problem in Y1. So you're going to click the Y equals button on your calculator. It's in the top left-hand corner. So click Y equals, and then next to Y1, you're going to type the original. So let's say we're going to check this one right here. So where you see Y1, you're going to type that original. So 2 minus 3x plus x squared, parenthesis, plus, and so forth. Step 2, type the result in Y2. So Y2 is going to be the answer, that x cubed minus 2x squared plus 4x minus 3 and so forth. And then the next thing you're going to press is the graph button, which is in the top right-hand corner. If you did it correctly, you should only see one graph because these two things should be identical to each other. If you're seeing two different things, then that means you made a mistake. The second one here says subtracting. So use the same y1 and y2 like we did here, but then in y3, you're actually going to type y1 minus y2. And you can see alpha, y equals, trace, y1. And you'll see that those two should be 0, because if you subtract two things that are equal, you should get 0. And then you can use the trace feature. And the third way is comparing values. So use the same y1 and y2, but instead of press graph, you want to do second graph, which will give you the table option. Again, you can play around with those. There are different ways to check it. You can always Google TI-84 comparing graphs, and you'll see a whole bunch of videos there. Okay, moving on to the next page. Example 3, use the calculator to determine if this polynomial right here is equivalent to this one. So what I'd like you to do is use your calculator and type this first one into y1, and then type this second one into y2 of your calculator. Go ahead and do that, and then press graph to see if you think they're equivalent or not. Okay, You will notice in this first picture here, I have my y1 and I typed the first one, and then y2 and I typed the second one. Now when I hit graph, I see that I have two different lines here. That tells us that these two polynomials are not equivalent to one another. If you have the color screen calculator, you actually see one trace over top of the other, but if you have the regular calculator, you will not necessarily see that. What you can do though is use your arrow keys, and you can do this on either one. Use your arrow keys and go to the left till this right here is highlighted. And then once you have this highlighted, you can press the enter key, and you'll notice that you can change on this one, you can change the colors. On the regular gray screen calculator, you can change the thickness, or you can make one a dotted line, and then you'll be able to see them trace over top of one another. Okay, the next thing we have here is opposites of a polynomial. To find the equivalent form of the polynomial for the opposite or additive inverse, keep in mind those two words mean the same thing. Change the sign of every single term. This is the same as multiplying the polynomial by -1. So what we have here is example 4, right? Two equivalent expressions for the opposite of the following polynomial. So we want to write the opposite of this. So one way we can do it is change the sign of every single term. So -4x squared, because it's a positive 4, making it negative, then plus 6x to the fourth minus x plus 7. That would be one way, or it says multiply the entire polynomial by a -1, which we could write like this. And I just put the negative out front, which implies multiplying it by a -1. So with that, when you look up here, we can see that these two are opposites each other, because here you can see that it's a positive x squared, -3x plus 5, which is what we have in the parentheses, but we're multiplying it all by a -1. Now what we're going to be doing is looking at the subtraction of polynomials. Well, first thing, just like we did in the previous page of examples, you have to eliminate parentheses first, which means you need to distribute, in this case, a positive one here, but now we have to distribute a -1 in front of that second set of parentheses. The first set, the signs do not change because we are distributing a positive value. Whereas in the second set, we are distributing a negative. So we have a -1 times a -2x to the fifth, which is plus 2x to the fifth. And that'd be a -1 times a positive x to the fourth, which would be minus x to the fourth, and then plus 4x cubed. And then lastly, you would have plus 3x squared. Now, just like we did previously, you want to combine like terms. If you need to reorder it first, 9x to the fifth, there's one of those, and a 2x to the fifth. And then we have minus x to the fourth, plus 4x cubed, plus an x cubed, minus 2x squared, plus 3x squared, and a plus 4 that we have. Now we can easily combine the two that have a degree of 5, the two that have a degree of 3, and the two that have the degree of 2. So we have a final answer of 9 minus 2 is going to give, or 9 plus 2 is going to give us 11x to the fifth minus x to the fourth. This would be plus 5x cubed plus x squared, and lastly plus 4. And that would be our final answer there. Again, you'd want to make sure you can use your calculator. Type this into y1, type this into y2, and make sure those graphs line up. Okay, now what I want you to do, pause the video and try example 6. Okay, you can check your answer with mine. 4x to the fifth plus 5x cubed minus 9x minus 5. Okay, the last page here. So problem solving. A 7-foot by 5-foot hot tub is installed on the outdoor deck, measuring W feet by W feet. Find a polynomial for the remaining area of a deck. Note, anytime you have to find a difference in the areas of two figures, you take the area of the big and you subtract the area of the small. This formula right here is super important. You want to make sure you remember that this is what you need to use anytime you face problems like these. This kind of problem, it's important that you understand how to do this. So we have a deck, and we're putting a hot tub on the deck. It says our outdoor deck measures W feet by W feet. So let's think, okay, we have to think W feet by W feet is the deck. So I'm going to represent my deck using this black here. And it tells us the size of the deck. Oops, actually, let's go back here. Since the size is W feet by W feet, that tells us the deck is going to be a square because it's the same measurement on both sides. So W feet by W feet. Now we're putting a hot tub that's 7 feet by 5 feet. So let's just say here is my hot tub. We have 7 feet by 5 feet. So here's the water. It says find a polynomial for the remaining area of the deck. So we want to find a polynomial that represents all this black shaded stuff that's left over. So that's where we have to take the area of the big and subtract the area of the small. So first thing we have to do is find the area of the deck. Well, we know area for a rectangle is length times width. So we know we have to take W feet and multiply it by W feet. If you need to, you can reorder this just so you can see a little bit easier what's going to happen. W times W is W squared, feet times feet is also feet squared. Now we have to find the area of the hot tub. I'm going to do this one in red just so I can see the difference. So the area of the hot tub, length times width again. So now we have 5 feet and we have to multiply it, squeeze it in here by 7 feet. Well, 5 times 7 is 35. Feet times feet is feet squared. Now we have to take the area of the big, which is the deck, and subtract out the area of the small. So we have to take W squared feet squared and subtract 35 feet squared. You'll notice both of these have a feet squared, so we can factor that out and just write it as W squared minus 35 feet squared. And that would be our answer here. Okay, the last example we have. Example 8. A company manufactures and sells calculators. The company determines that when they sell X amount of calculators, its total revenue is given by the R of X equals 45X. Read about the total cost is C of X equals 4,000 plus 15X. It also tells us that profit is found by taking the total revenue and subtracting the cost, which is R of X minus C of X. Part A says find a polynomial for the total profit. So we want to find the profit. So it tells us here that profit is P of X, and it's found by taking our revenue and subtracting our cost. Well, R of X is revenue, which is 45X. However, we have to subtract this cost right here. Now, we have to be very careful. When we subtract that, when we write it, we cannot just write it like this because this would only be subtracting that 4,000. We have to make sure we put this in parentheses because we need this negative to get distributed to both of those. So now we have 45X minus 4,000 and plus, or we can just write plus a negative or minus 15X. And then we want to simplify this, which would simplify, we have 45 minus 15, which would be 30X minus 4,000. And that would be our polynomial function for the total profit. The last thing is what's the total profit on the production sale of 250 calculators? So we want to find the profit on 250 calculators. Well, if we know that this function is at 30x, so 30 times 250 minus 4,000. And we can use our calculators to do this. So we have 30 times 250 minus 4,000. And we get an answer of 3,500. And we're talking about profit, so that would be how much money they make when they sell 250 calculators. Okay, that's all we have for the video on 5.4. Hope it was very helpful for you, and please reach out if you have any questions. Good luck.